Hello there, my name is Adera from Kodarasa, and today we're going to continue with SQL commands. We're going to cover aggregate functions, we're going to cover case statements, union, operators, name it all. We're going to cover that. So let's jump right into it. We're going to start with aggregate functions. What are aggregate functions? It is a function that performs a calculation on a set of values and returns a single value. So basically the mathematical formula of it performs a set of calculations and then returns something at the end of it. We have different types of aggregate functions. We have mean, the common ones are mean, max, count, average, and sum. We're going to look at those examples on SQL. So I like to use, we've already done the ERD diagram for this, the school management system for this, so go back and see the insertion of this table, the creation of these tables, and see how we came here. But yeah, I'm going to use the school management system database that I've been using for this course. So I'll start with querying the student tables, which is what we are using for this case. It has ID, first name, last name, class ID, classroom ID, duty ID is prefect. So I want to get the minimum first name from student, alphabetically the one that comes earliest. So if it was numerical, we'd get the least value, but in this case we're going in an alphabetical order. So the minimum first name in this case is Gatabaki. If I am going to order this by first name, so order by first name, I won't indicate whether it's ascending or descending, but you can see Gatabaki comes first. So that's the minimum value for all the students. But we can also do this by grouping. So in the grouping of duty ID, in our case here, I want you to give me, for each grouping, start with the minimum. Like, give me the minimum. Sorry, not start with the minimum, it's not order by. So we have here Karunji, Kimathi, Mwaki, Karendi, Gatabaki. So in duty ID 4, we have the minimum. So we can test this out by, so select all from student, not group by, order by first duty ID, and within the duty ID, order by first name. So we're demonstrating this main thing. So we can see in duty ID 1, Karendi comes first, Muisweri, Mwendia, and then Waridi. In duty ID 2, we have a different ordering. So this is mostly trying to validate this query here. We have the minimum for each group. We saw Karendi came first in the duty ID 1 category. So that's just trying to validate that. Anyway, let's continue. We've seen the main aggregate function. Select count all from student. It gives the count of all the students. Of course, you can also now group by. So let's do a group by. For each class ID, give me the count of all the students in that class ID. So we have class ID 1 has 6 students, 5 and 5 for 2 and 3. Let's continue. The question is, get me all the students. Get me the value, the count of students where the count is greater than 5 in a class, basically. So this is how we do it. When you have such a query, and you can see it's only class ID 1 with 6 students. So we've seen mean and count. Let's go to max. Give me the maximum using the last name, similar to what we did, but in this case we're using the max and we're using the last name. So similar to what we did when it came to mean. Again, for group by classroom ID, similar thing, Monene, Sororo, Nwaji. We can validate these once again by, come back here, select all, order by last name. Descending. I want the greatest value to come first. So I'm ordering by duty ID. Here we were ordering by classroom ID. So let's do that, classroom ID, so that it's completely similar. And you can see here, so we start with classroom ID 1, and we start with Nwaji, Mutweri, Mukiri, Mwende, Masavu. So you can see they're going lower as we go in terms of the alphabetical order. So we're starting with the max. In this case, the max is Nwaji. So back to the max query, where we were grouping the classroom ID, we can see why Nwaji came first, came there, Nsororo and Monene. I was just trying to validate that really. So we've seen max, min, and count. We have two more. We can also check the sum. We're going to use the activity table for this. Let's look at what it looks like for now. We have a column number of students that has the number of students in that activity. It is not accurate. It's just an inserted value, but we'll get into that later. So select sum of all the students, sum of the number of students from activity. So this will sum all these columns and give me the total, and we're getting the total is 39 for all the activities. We can also get average. So we have 6 activities and we have a sum of 39, so the average will be 39 divided by 6, 6.5 and 0.000. But here we've seen different aggregate functions in this case. We can also introduce, so this is something we didn't cover last course. It's not really an aggregate function, but I'm going to cover distinct here because I want to talk about count and distinct. So distinct gives me the unique values within a table. So select distinct class ID from student. You've seen there's many students belonging to many classes. So we can, for instance, classroom ID 1, class ID 1 would be in many students. So that row, that value will be repeated, but I only want it to appear once. So select distinct will only give me 1, 2, 3 because those are the unique values. And I can do the same, count distinct class ID from student. So instead of counting all of that, I'm getting the distinct ones, and that is Ray. Without the distinct, here's what I would have. I would have 16. So you can see what the distinct does. It gives me the unique value, and I can apply my aggregate functions on this distinct select. Let's move on. We've covered aggregate functions. I hope that's very clear. Feel free to ask any questions as we go on the comment section. We're going to check on operators. I covered a bit of this on the very beginner video, but we can also perform different operators. We have arithmetic ones, we have comparison ones, we have logical ones. Sometimes they tend to not really be categorized in a common way, but at least arithmetic, that's very clear. You have your plus sign, you have your minus sign, like addition, subtraction, division, multiplication, modulus. Those are very clear, but I digress. I do like saying that word. So select 5 plus 2, you have 7. So I'm not going to do this one. Of course, we expect 10 here. And let's use an example from the table. We saw sum of number of students, which was an aggregate function we were able to perform on the activity table, and then over the count of all students. So we're basically getting an average here, and we have 6. We already saw it was 6.5 when we did that earlier, so yeah, 6. Let's move on to comparison operators. So select all from student where, for instance, I want to get all the students whose first name is Mokevi. And here notice how I'm very specific in how I write my letters, in whether something is capitalized or not. Very specific, because if you mess it up, then SQL won't match it correctly. So select all from student where first name is Mokevi. I can see there's 2 students whose first name is Mokevi. There's Mokevi Mukiri and Mokevi Karimi. So that's the equal operator, where equals to. We can also check where is not equal, and in this case we have 2 different ways of doing it. an exclamation mark and an equal sign, or greater than and less than, as you can see here. So that's how to do the not equal, like, to something. So in this case, get me all the students that are not prefects, and you can see all the students returned here have false when it comes to is prefect. Select all from duty where number of students is greater than 15. So these are all the duties whose number of students is greater than 15. We have toilets and pavements. I don't know why that was funny. We can also do the ones that are less, and we have 10 and 7. And in the same fashion, we can do less than and equal to and greater than or equal to. And in this case, 15 is now included because it's part of the equation. Everything that is equal to 15 and above, everything that is equal to 15 and below. And yeah, that's it on comparison operators. Let's move on to logical operators. Select all from duty where name is equal to dining hall or name is equal to hall. So or in this case gives me what matches on the first side and what matches on the second side. If we have a case where it only matches on the first side or it only matches on the second side, then it will give me the values for the one that it actually matches. So give me either of these. If they both match, perfect. You'll give me this selection and this selection together. So we have dining hall and hall because we have two duties. One is whose name is dining hall and the other one whose name is hall. We can do the same using and here we'll see we'll return nothing because we don't have such a scenario where a duty, in this case it's a duty. A duty is both called dining hall and also both called dining hall and hall. So that's why we use or in this case, because we want both of these. Select all from student where class ID is equals to 1 and duty ID is equals to 1. So before we run the full thing, let's look back at the student table. We can see there's such a case where we can have a classroom with 1 and also a duty with 1. Because within, like for instance, looking at this list here, we're seeing 1, 1, 1, 1, 1. And in this case, we also have a student whose duty is also 1. So we expect that student to be returned in this case. And it's actually 2. This is because at the very bottom, we also have this student here, class ID 1 and duty ID 1. So it wasn't magical numbers appearing, just to be clear. But yeah, we do have two students that match those conditions. So as long as they both are true, then return that. Select all from student where ID is between 5 and 15. So this covers ranges where instead of saying less than this, greater than this, and less than this, which you can also say, you can also use between in this case, which is a shorthand and is also more Englishy. It's more closer to how we speak, so it's also a bonus. So when you look at the IDs returned, we have 5 all the way to 15 and just that. We can also now, we've seen between. Another operator to look at is in. In gets you're given a subset of values and then it's in charge of checking everything that matches what is in that subset. So in this case, select off from student where duty ID is in this subset. So in our case, this can be a subquery. We'll cover subqueries very soon in this video, not in another video. Select off from student where duty ID in 1 and 2. So we do have all these students whose duty ID is 1 and 2. And as you can see, they all have 1 and 2. Yeah, I hope that's clear. Let's introduce a whole other operator, that is the like operator. Like is used to pattern match in a sense. So I want to return all the students whose name starts with M. And notice how in this case I used capital M. It is case sensitive. If I used small m, I would not be able to match as I want. So in this case, I'll get Mukethi, Mwendia, Mutethia, Mudhoni, Muisweri, Mate, Mwaki, Mwende, and Mukethi again. So these are all the students whose first name starts with M. Let me try and use a small letter in this case, and you'll see that we have no student returned. This is because, as I said, this is case sensitive. So when using like, be very specific when it comes to case and matching every specific, like the pattern as you want it completely. We can do a similar one. Get me all the last names that end with I, and all these last names here end with I. Select all from student where first name is like, and then we have ND in the middle. Everything that begins with whatever you begin with, but I have ND in the middle, and then it continues. So I have this list here. The first name, we have Namaganda, we have Mwendia, we have Kendi, we have Mwende, and we have Karendi. They all have ND in the middle. So that's the match. So what happens when I want to match? Let's say some people use first name, like capitalize their words, and others don't. But I still want to match them anyway. We want to use I like for this. I like ignores, first it converts it to a common case, and then after that does the matching. So in this case it is more expensive. It does take up more energy. But it's doing more work. It's doing more work. So in this case, prefer like if possible, especially the app like Postgres has optimized that for you. You have databases having done that for you, so don't worry about it. It will actually match. It will not take up a lot of your operation, your speed, your compute space, time, space, energy. I don't know why I keep saying energy when it comes to computers. Pardon me. But yeah, select all from student where first name I like M, and here we'll get the same list, but notice how they are capitalized and they don't have small cases. Another similar one, we can also negate. I don't think we've used not, but yeah, I want a scenario where I want, for instance, let's go back to this. Not basically negates. It's like not equal, but yeah, not like not what you want it to do. So we already covered, for instance, this query here. Select all from student where duty ID in 1 and 2. If I want everything that is not in this, I'll do the same, and as you can see, we have 3, 4, 5 which are not in 1 and 2. Similar to that. Another one, select off from student where first name is not like M. So we are doing what we've been doing but negating. So here I'll get all the first names that don't start with M, and you can see them: N, K, G, K, K, W, K. Alright, so we've covered many operators. Let's look at one more, exists. So exist is similar to in, but it has some differences. In we were able to query without a subquery, but when it comes to exist, you actually need the subquery, and in this case a subquery is a query within a query. So if I use exists here, it wouldn't work, and that's because exists expects an output of true or false. You can see here syntax error at or near exists. So put it back and that will work. So that's just one difference between the two. Exists, basically the first query will execute if the inner query, that is the subquery within the exists, is true. So let's look at an example here. Select all from student where exists, select all from duty where ID is greater than 5. So before actually running these, let's look at duty and see the IDs. We have 1, 2, 3, 4, 5, and the query says where ID is greater than 5. So when I run these, I expect it to return nothing. So that will be false. Because of that, I expect no students to be returned. But if it were 4, which is something I expect to be true, then I will have all these students. And notice how in this case the duty ID is not mattering, because exists only checks whether the subquery is true or false, and then gives me all the results for the first if it's true or false. But if it was a case of in here, I would only get the ones where ID, let's correct this, selector from student where I would have to use, okay, ID where duty ID in. So in this case it will only get me the ones where duty ID is greater than 4. Just a little detour, but I did explain that. Let's put it back as it was. This was 5, so no students returned because we don't have that subquery is not true. Selector from student where not exists, I've covered not, basically negates. So not exists in this case would bring all the students because the subquery is false, but then it negates that, so we end up with true. Let's just look at SQL operators. We've gone through the code first, but yeah, like I said, they used to specify conditions, perform calculations, and manipulate data. They are used to filter, compare, and perform operations on data within a database. You've seen the examples: arithmetic, we've gone through them, addition, subtraction, multiplication, division, modulus. We've actually not covered modulus. So what is modulus? Modulus is basically give me the remainder after this computation is done. So 8 divided by 2 gives me 4. There's no remainder in that case. But if I were to use something like 9 here, I expect a remainder of 1, and that's what modulus really does. So yeah, those are the 5 arithmetic operators. We have comparison operators, we've gone through them: equal to, not equal to, and the different ways to write not equal to. We have greater than, less than, greater than or equal to, less than or equal to. Use either. We have different logical operators. We have and, between, exists, all, like, not, in. And 3 that we've actually not covered in this video. We have some, all, and any. I chose not to cover that because they're not commonly used, but read up on it. I don't want, like, it's sort of not so beginner friendly in a sense. I will try and cover it if people ask about it, but I will choose not to do it for this specific video. After this, I'll maybe move to a more advanced topic, so that's exciting. So if you are not a beginner and you've been feeling like this is too much beginner stuff, don't worry, the next video is going to cover you. So let's cover another thing, that is case statements. What are case statements? They are used to create conditional expressions similar to an if and then structure. So if you're new to programming, that's basically conditional state expression, in that if this is true, do this. If this is true, do this. Else, do this. So that's basically what it's trying to say. It allows you to apply logic within your SQL queries, which is helpful for transforming data or applying custom categorizations. So before we go further into that, before we go to case statements, let's cover one interesting topic, which is union and union all. I didn't really want to put them within the operators because I didn't really feel like they fit there either. So what is union? Basically, union is where I have a set of outcomes from one query and put them together with a set of outcomes from another query. Some rules to this, because there are rules. You expect them to have the same columns and order returned. I can't have a case where this is ID and then this one is just name, or ID and name. Then they won't match. At the end of the day, I want the result to look similar, like it came from one query. So that's why you need the same set of columns and the same order in this case. So I have explained what it is. Let's look at an example. We have run this query a lot of times where we were querying all the names that start with M. Let's also query. So we have a number of 9 here. We have 9 names first names that start with M. Let's look at the second names that start with M, and that is the last name. We also have 9. Of course, we have cases where the first name and the last name also start with M. So when I run these two, I expect now a summation of all of these cases. We have 13 unique. So that's what union does. We have another one which is similar to it, which is union all. I'm going to run the same query, but instead of using union, I use union all. And notice I ran the same query, but this time our output is 18. We have 18 rows returned. So what is the difference between union all and union? The only difference is that, I mean, there may be other differences, like maybe the fact that, anyway, let me first start with the only difference, with the main difference. The main difference between union and union all is that union deduplicates. That's why we have a less value number of rows than the other one. So union all has 18 rows and union has less rows, which is 13 rows. So union removed all the duplicates. And the reason I was saying we may have other differences, that the fact that it's also deduplicating means that it is using more resources to do that. So it may be slower in this case, it may be more expensive to do it, but of course there are so many cases where you want unique values and not repeated values when you want to return something. So anyway, basically that's what union and union all does. Let's look at case statement. I've already introduced that, and I'm going to use subject table for this. So let's first look at the subject table. We have ID and name. So let's have this scenario where I want to put these subjects into different departments. I don't want to create a column for this yet. I maybe just want to test it out. And in my scenario, I have music, home science, computer studies, business, agriculture, all going to a technical department. I want geography and history to go to humanities. I want biology and chemistry and physics to go to sciences. I want Kiswahili and English to go to languages, and anything else not specified. Poor maths. So yeah, when I do that, I'm able to now categorize them. You can see mathematics is our else, like we didn't factor you in, so not specified. We have our languages, we have our sciences, we have our humanities, and we have our technical department. So that's one use case for categorizing your things. You can even have an example where you want to categorize salaries, where like these are the people with high salaries, these are the people with low salaries. You may try to categorize your students by regions they come from. I don't know why you'd want to do that. It does feel a bit like, why are you interested in categorizing people by their addresses? Maybe you want to have a bus pool for picking up kids. So that's a good use case. So you're like, okay, kids from this region will be picked by this bus. That's a good use case. It's not it's not discriminating in any way. It makes sense. Anyway, another example where we can use case statement is in aggregates. We've covered aggregates, and let's use count for instance. Select count, and then case when is class teacher is equal to true, then 1. So every time we interact with a class teacher, and like a teacher who's a class teacher, then add to that count. So for all of these, so we have, let's say 3. Yeah, we do have 3. But let's say we have 4. So each case where, like each row where the class teacher is true, then it's counted. So in this case, we'll have a return value of 4, if there were 4. So we're going to use this. We're going to do the same. So have to select, one is all the class teachers and the other one is all the non-class teachers, and you can see the count is 3 and 3 for both, because we have 3 teachers who are class teachers and 3 who are not. This is similar to this, a different way of writing this really. It's sort of anyway, select count all is class teacher from teacher, group by is class teacher. So basically it does a similar thing, but yeah. Another use case for case statements is you want to use it in an ordering. So we were able to categorize our departments, but we want to categorize our subjects based on the departments. In this case, department is not very clear. Like we've not defined a column called department, but we want the ones that belong to this grouping to be in a different order. For instance, we want our languages to come first, followed by our sciences, followed by our humanities, then the technical, and anything else comes last. So order by, and then we have this ordering here. So we do expect our languages to come first in this case, and as you can see, that's what happened. We have Kiswahili, we have English, we have physics, chemistry, biology. Those are the sciences. We have our humanities, and then we have our technical department, and mathematics comes last. So another thing to note here is we are ordering by this case as I have listed, but also notice how this seems to not be in any order, the names appearing, the subjects. You can now, of course, now still order by name. By default it will be ascending. So after ordering by the department, then also order by name. In this case, English is coming first, biology is coming first within the sciences, geography is coming first, agriculture is coming first, and lastly mathematics. So that's how you can use case statement in your ordering. And lastly, we can also use our case statement with group by. And we saw group by is mostly used together with aggregate functions. So let's look at an example. I'm not going to go through the case. It's the same literally case statement. And after all that, after the categorization and then give this name, we've labeled all that as department. So that is our one select column. And next to that, I also want to give me a count of all the subjects in that department. So this count, call it subjects in department. The alias is optional. I don't think I've covered aliases. If you want a case where you want to rename something that wasn't already there, you can use this cool thing called alias, as, whatever you call it. See how without it, this column is called count, but with it, we get to determine, to be very clear, descriptive really, of what we're talking about. So these are the number of subjects. I could even be more clear and say number of subjects in department. So in this case, we are seeing under not specified, we only had mathematics there, we only have 1. Under humanities, we have 2. Under technical department, we have 5. And sciences, we have 3. And languages, we have 2. So that's an example of how we can use our case statement in a group by function. So you've seen how to do it for group by, for order by, for a whole other column, creating a whole other column when we're doing department. And we can also use it similar to this in an aggregate. Yes, this time without the group by. And the last thing we're going to cover is subqueries. What are subqueries? We've sort of covered this in many ways. So subquery is basically a query nested inside another query, a query within a query. It is used to retrieve data to be used in the main query. We've seen examples of this. So first, the inner query is computed, and then the results of that will determine the results of the other outer query. We saw the example using in, we saw the example using exists. So in this case, the results of the inner query determined the results of the outer query. And we have different uses for this. It breaks down complex queries, and we also use it when you need a result set to operate within a larger query. We have different types of subqueries. We have a single row subquery. I'm actually going to cover two. We have a single row subquery and we have a multiple row subquery. So a single row subquery is basically as it sounds. It returns one row of results. So in this case, I'm going to use operators like equal, less than, equal to, greater than or equal to, greater than. And the other one is multiple row. In this case, I expect multiple rows to come out. And for this, I'm going to use operators like in, any, all, some, basically. So let's look at examples of this. So as I said, a single row query expects a single row to be returned in the subquery. Is our example here. Select ID from duty where name is equals to whole. I only have one row returned. If I did something like here, okay, let me first run the full query before trying to do my detours. So I only have one ID whose name is equals to all. So select all from student where duty ID is less than or equal to 5 in this case. So I do have all these people less than or equal. So basically 5 is also included. All these students are returned because they match. And like I said, we do expect it. I can't use so let me try to return more than one row here. Select ID from duty where name, like whole. So basically it will give me everything that matches whole or has more words in front of it. And I get an error, more than one row returned by a subquery used as an expression. So this is an